To optimize the scene, we need to make proxies. In the Corona renderer, proxies don't improve rendering time. They do help keep a smooth viewport performance despite many objects in the scene though, and they help make the file smaller. First, we have to check the number of polygons for each object and make a proxy for any object that has more than 3000 to 4000 polygons. To do that, go to the plus sign, configure viewport, statistics, and check mark total plus selection to show the total amount of polygons and the selected object. Press 7 on the keyboard, and on the left side of the scene, we can see the total number of polygons and the number of polygons for the selected object. For instance, the side table has 1050 polygons, so we don't need to make a proxy for it. But the sofa has almost 2 million polygons, so we'll definitely need to create a proxy for that. Start by isolating it, go to the group and ungroup it. Then select only the sofa and isolate it again. We'll first need to attach all the parts together. To do that, select one part and go to Attach Leads, select All and press OK. Right-click on that, select Corona Proxy Exporter in the window, select the folder where we want to save and export it. If ever we want to see the object, we can change it to full mesh in the modifier panel. We'll continue to repeat this process for all the objects that are heavy in the scene. Next, we'll want to start setting up the camera for animation. To do that, select the still cam for each area that we made and make a copy of it. We'll start off with Office Cam. Go to the camera, select Camera, Ctrl V, and then select the camera and rename it to AC_Office. With the dolly camera, move back. In Environment and Clipping, remove casing from the view by slightly adjusting the number. Open the time configuration window and in the frame rate, check mark Custom and FPS to 24 to have 24 frames per second. In the animation, change the start time to 0 and end time to 300 and press OK. Then go to the save frame by pressing Shift plus F and open Render Setup to change the aspect ratio to HDTV video. And press Auto key to turn it on. The area that we are placing the camera in is the starting point. With the dolly camera, move forward to the frame 150. This will be our endpoint. Make sure default in and out tangent for new keys is linear to allow the camera to ease in and out. Then press play to check the speed and camera. To see a preview for the camera, go to Tools, Preview Graph, Viewport, Create Preview Animation. In this window, set the range to 150 since our camera range is 0 to 150. Then check mark frame number and camera view name. In Visual Style, change the preview presets to standard and preference to faucets. Output will be saved in this folder. And if we want to keep all the previews, we'll have to move it to a separate folder since the new preview will override the previous one. Here is the preview for the first camera. The next one is going to be for the dining room. Select the camera and Ctrl V to make a copy of that. Then go to the top view and rotate it toward the dining room table. Next, go to the camera and change the name to AV_Dining. Using the dolly cam, pan, move it back and turn on Auto key. Move the camera to the right in the frame 150 and press play. And repeat the same steps to make a preview for that. Now we want to make a camera for the living room. To do that, select the living room camera, press Ctrl V, and go to the camera and change the name to AV_Living_01. Go to the top view and rotate it. Next, go to the camera view, move the bar to 0, turn on auto key, and move the bar to 150. Using rotate, walk through, and use the dolly cam to do a 150 turn toward the scene. We'll need to test the speed for each camera to make sure we have a constant and a smooth animation. The number of frames might change as we test and adjust the cameras. We'll continue to add cameras for each of the areas. Now it's time to submit renders for each camera. Go to the AV underline office cam. We'll want to start by setting our frame rate to 24 frames per second. Before submitting our animation, we should do a pre-calculation for our UHD. This will make our render go faster and will prevent us from having to calculate it for every frame. Depending on how many frames our camera has, we should set it up to render a frame roughly in the middle of the camera path. In this case, the camera path has 150 frames, so it's set to render frame 75. Next, we'll set the noise level limit to 0, set the time limit to 1 second, and turn off the noise. Now we'll want to set the UHD preset from frame to animation flicker free. Set the pre-computation to calculate from scratch and save the file. Then select the path in which we'll want to save our UHD. Since it's a single file, we can put it in the same folder that will submit the actual rendered XRs. We can now render without it taking very long. Once the UHD is finished, it will be saved in a UHD file. Since we've rendered out pre-calculated UHD, it's time to set up our scene to render the actual animation. To do that, switch back from frames to range. It should be set to 150. Then save it as an XR file in our destination folder. Set the noise level limit back to 5. We'll want to put the time limit back to 0 seconds and change the denoise mode back to high quality. Next, we'll want to set our pre-computation to load from file. It will automatically set the path to where we save it, but we can always click the path button to be sure. Now we are all set up and we can submit the animation to render. Now that you've got your camera animated, in the next session we'll be looking at post-production and the animation.